So the next section in chapter 6 is 6.3, which is really just vector basics. We kind of take a break from trig and do two sections of vectors, although we will use trig in and out of this section. That's why it gets thrown in here. So if you aren't really in, I guess physics would probably be the only spot you would have seen vectors. This might be kind of new for you. I will be using a lot of examples from physics when I'm talking about vectors, but we're just going to kind of talk about the theory, the math theory behind vectors, and won't get into the applications quite as much. So to start off with, let's just talk kind of about what the heck are these things. And we're going to just do this sort of from an intuitive standpoint, and then we'll write a more formal definition afterwards. The idea behind a vector, though, is that sometimes we'll have a quantity some quantities will involve both a magnitude and a direction. Some examples might be velocity would be one, which you might have seen, and forces are two pretty common examples. If you're in physics, you probably know exactly what I'm talking about. So if I said something like, the plane's speed is, let's say, like 550 miles per hour. This is not a vector, but if I said the plane's, I could turn this into a velocity by saying 550 miles per hour bearing 45 degrees. So now you know, rather than just some sort of speed 550, I don't know which way you're going. Maybe you're going away from me or towards me. I don't really know. But now we could say, well, wherever this person is, we do know that they're going this direction here, 45 degrees, and they're going 550 miles every hour. So the first one, this is what's called a planar or a scalar sometime. And then, so that's the first example. The second example, this is what we would call a vector. So really a vector is a quantity with a magnitude and a direction. So not just a number, but it also has a direction. All right, so let's remove the context now, and let's just talk a little bit about what a vector might look like. In terms of this definition I've kind of written down, it's still not really formal. That's probably as formal as I need to get, though. Another way to think about a vector is it's really just a directed line segment. So as an example, let's just say I have my coordinate plane here, x and y. And let's just say we have a vector. Let's start at the point 1, 2. Oopsies. So this is the point 1, 2. I'll call that point P. That's what I usually use for the initial point, but it really doesn't matter what letter you use. And we'll say that it ends up at the point 3, 4. So we'll call that Q. So here is a vector right there. We could also say, let's just do another example. Let's do -1, 1. And then we'll go to 3, -1 over here. So here's a different vector. So here's my first vector, and this is my second vector. So we would say, we could call this V for vector, and I'll put a little 1 next to it, and then you usually put a kind of an arrow on top. And then this one will be V2. So we'll say V1 is the vector with initial point P, what was it, 1, 2, and terminal point Q 3, 4, and V2, for V2 the initial point was P negative 1, 1, and the terminal point was Q, and it was 3, negative 1. So those are vectors. Now, if we did want to talk about, so these do have a magnitude and they do have a direction. Let's talk a little bit more about the magnitude of each of these. So the magnitude is really just the length of the vector. So for example, if I was looking at V1, by the way, I'm going to write V1. Instead of doing a full arrow, a lot of times you'll just see the top part of the arrow because it's a little bit easier to write instead of having to come back around. It's a very small detail, but it does make things a little bit easier when you're writing it. So either way is fine. So if I was going to try to figure out the magnitude of this vector, well, we would take a look at V1 and we could say, technically, this is really just the hypotenuse of a triangle, of a right triangle. So therefore, I could actually use the Pythagorean theorem or the distance formula, however you want to think about this. I need to figure out this length, and I need to figure out this length. So we would say, well, this one is x2 minus x1 would give me 3 minus 1, which is 2, and this is y2 minus y1, so 4 minus 2 would also give me 2. So therefore, the magnitude of V1 would just be 2 squared plus 2 squared, and then we would take the square root. So we end up with the square root of 8, which reduces to 2 times the square root of 2. We denote magnitude using kind of an absolute value symbol, but so we don't get too mixed up. A lot of times you'll see 2 absolute value symbols around it. Sometimes you'll just see 1. But so this is sort of the absolute value of V1, I would say, is 2 root 2.